This is Sir William Rowan Hamilton. It is because of him that your GPS works, and that is the truth. The things that he discovered and the technology that flowed from that causes us to have the things that we have today. So, thank you, Mr. Hamilton. All right, is it possible to draw a path through this graph that touches every vertex exactly once? Whoa, what? All right, let's back up to the previous lesson for just a moment. An Euler path is a path in which each edge is crossed exactly once. But now, we don't care about crossing every edge. Let me point when I say that. We don't care about crossing every edge. Every edge. We care about touching every vertex. So here's the deal. Let's pretend like this is a map of 6 cities. City A, B, C, D, E, and F. And these are roads that connect them. I don't have to travel every road, but I do need to go to every city. That's really what it's saying. So is it possible to draw a path through this graph that touches every vertex exactly once? And if so, what is it? Now, there's more than one answer. But I'm going to start at F because he's just dangling out here all by himself. I'm going to just start at F, and then we can go up to D. I'm putting a little dash. I'm kind of getting in the habit of putting the dash now because in later lessons, we're going to need to put some stuff around that dash, like if it shows me how many miles or whatever. So I can go F, D, then A, then B, then C, then E. Okay, that is not the only answer. I could go F, D, A, C, B, E. I can go F, D, B, A, C, E. I could go F, D, B, E, C, A. There's a lot of stuff I can do. I can say everything I just said in reverse. All those, there's a lot of answers. So this is a Hamiltonian path, not an Euler path. All right? So is it possible to draw a path through this graph that touches every vertex exactly once and you finish on the same vertex that you started? And if so, what is it? So what is that path? And we're actually going to go ahead and call it what it is. That's actually a circuit. So is it possible to do that? Let's find out. What I want to do is start and end at the same vertex and only touch each vertex once. Obviously, the first and last one I will repeat, but that's the starting and ending point. So I want to basically, here, let me grab this from a previous one. I want to start and end at the same vertex and hit every city. So A, D, C, B, back to A. Now in that case, I've crossed every edge, but I'm also touching every city, right? So is it possible? Let's try it. I'm going to just start at E because I feel like it. So E, C, B, A, D, F. Oop, I got to go back to E. E, C, A, B, D, F. Oh, got to go back to E. Let's start at F then. F, D, A, B, C, E. Oh, got to go back to F. All right, this one's a no. So it is not possible. Now, I know I gave up very easily, but if you're in the context of the previous lesson, then you're probably thinking, oh, there's a shortcut. Okay, so remember previous lesson where we had this really awkward thing where exactly 2 vertices have a degree that is odd, or all the vertices have an even degree. That sort of thing. I have bad news. There's no shortcut for this one. You either find it or you don't. All right, so here goes. Hamiltonian path is a path that is Hamiltonian. Ha ha. No, I'm kidding. In which each vertex is crossed exactly once. Again, I don't care if I walk down every road as long as I go to every city, right? So I have to go to A, B, C, D, E, and F. I don't care if I travel this road or that road. It doesn't matter, all right? A Hamiltonian circuit is the same thing. It's a path in which each vertex, that's different from Euler. Euler is an edge, is crossed exactly, I would like to underline that, exactly once, and you begin and end at the same vertex, which again, that does imply that the first one and last one, you get that one twice. It's kind of implied in there, but that's not really an issue. Okay? So here we go. Let's do it. We're going to see if we can find a few of these, and some of these you may want to try on your own. Now, again, let me remind you, this is Hamilton, not Euler. Euler, we cross every segment, every edge. Hamilton, we touch every dot. All right? Does a Hamiltonian path exist? Yes, it does. Trust me, it does. Does a Hamiltonian circuit exist? Yes. How do you know? Because you're about to find it, and it's going to be the easiest one you've ever done. A, B, C, D, E, A. All right, so that actually was the circuit. Let's back up and do the circuit. So yes, A to B to C to D to E, back to A. That's not the only answer. You can go B, C, D, E, A, B, or you can go this way, or you can start with D, you can start with E, you can go the other direction. There's multiple answers. There's actually 10 answers, exactly. Does a path exist? So yes, and in this case, I'm just going to start at A and do the same thing. So A, B, C, D, E, and I'm not going back to A. So A, B, C, D, E, and then I know your gut instinct is, well, we haven't traveled this road. This is not about traveling road. This is traveling roads. This is about going to cities. So don't go there. All right, next one. Does a path exist? Can I get every vertex exactly once? Yeah, I think I can. So A, D, B, C, well, okay. E, B, C, A, D. That was it. I found one. Okay. Here's what just happened. I tried something and it didn't work. I tried A, D, B, C, and then I was stuck. I couldn't go and hit that last one I hadn't gone to. So maybe that one doesn't work. We'll try something else. So I started at E this time, and then I went E, A, D, B, C. All right, cool. So that'd be a yes. E, A, D, B, C. Cool. E, A, D, B, C. Not the only answer. It's just an answer. Does a Hamiltonian circuit exist? So can I begin and end on the same vertex? I'm just going to try. We'll see. I'm going to start at B because I feel like it. Dun, 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 dun. No. Dun, 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 dun. Dun, nope. Dun. All right, here's what just happened. Dun, 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 dun. Oh, man, I didn't get to E. Dun, dun. Dun, 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 dun. Nope. Dun, 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 dun. Dun, 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 dun. Nope. Dun, 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 dun. No. How do you know when to give up? When you've tried it for 5 minutes. That was a quick 5 minutes, wasn't it? Okay, does a Hamiltonian path exist? If so, what is it? Can I hit every vertex? I don't care if I start and end at the same place. That's the path. I'm starting at D because he looks the most promising. No. I don't know the answer to this one either. I'm experimenting. And again, there's no shortcut. I'm starting to think I can't. I'm either always going to leave out the G or something else. I can. I did. Yay. Okay. I can start at F or E, either one. So that was it right there. Not the only answer, but here's an answer. F, D, E, A, B, C, G. Okay, does a Hamiltonian circuit exist? Can I start and end in the same place? D is so important. I think that's going to be the difficult one. I'm leaning towards a no on this one. Go with no. Okay, there are more for you to practice with.